we're going to look at thesis figures, and in this particular case, we're going to look at photographs. And photographs are one of those visual things that we do, and when we do photographs, the concept is we want it to illustrate as good as possible what we want to see. When we deal with photographs, we often talk about resolution. Again, this is from dictionary.com. Resolution is an act or process of resolving or separating something into constituent or elementary parts. So when we look at resolution on a photograph, we are looking at how well does it differentiate one thing from the next. Because we want to have something that does differentiation well. We don't want something that's not very good. Resolution can also mean the degree of sharpness of a computer-generated image as measured by the number of dots per linear inch in a hard copy printout or the number of pixels across and down on a display screen. When you look at what computer screens looked like 25 years ago compared to what they look like today, they are two totally different things. Nowadays, they have resolution, which means they've got a lot of dots per inch, but they've got good resolution compared to what they had a long time ago that had very large pixels and it didn't give you the resolution. Now, a pixel by definition is the smallest element of an image that can be individually processed in a video display system. When we look at it, each one of these letters over here is broken down into pixels or smaller pieces, and when you start looking at them and you blow it up quite well, you can actually see the different parts of it. A pixel being a small element in there. DPI is dots per inch, and dots per inch, basically the larger the DPI, the better the resolution. Also, when you go out there and you start dealing with these, the larger the DPI, the more space it is going to occupy in your computer. I have got photographs that fill up 50 meg just on a single photograph because they've got a tremendous amount of DPI and they've got great resolution in there, but they're huge photographs. So you have to figure out which way things are going to trade off. In general, your cell phone is going to give you less DPI than a good camera. And when you take pictures, it's always advantageous to have a decent to good camera, and don't expect your cell phone to give you the same thing that you would find out of a really good camera. Resolution, what are we looking at in here? We've got a photograph in here. This is the size of the native photograph as it imported in, and that's not a bad photograph. It's not a great photograph. If we blow it up, it looks like this, and all of a sudden you go, wait a second, that looks horrible. You can see all the wavy lines and all the on the edges of it. You can begin to see pixels in there and the individual little parts. And if you look at this particular spore down here, you can see that it doesn't have sharp edges and it's got really lousy resolution. Here's another picture. It imported this size. This was taken with a digital camera, totally different kind of digital camera. The one on the top, it said it had 640 pixels across the top. This bottom one has a resolution of 5 megapixels, something like that. So we blow it up to about the same size, and what you can see is you can see a tremendous amount of detail. If you look at this area in here, you can see how the lines are actually clear. They don't look broken apart, and this is basically a same size format, maybe a little bit larger format, but you can see everything you need to look at. Resolution on this one is very good. So resolution makes a big difference in here. Another thing that makes a big difference is cropping. I got this photograph, driving down the road, saw this, had to stop, pulled out my camera, started taking pictures. What do I got here? I got a balloon. Now, you're going to put this into your thesis. Do you put the photograph look like that? Or do you go out and do you crop it to make it a different size? I mean, you can actually see the shadow of the balloon in the trees below. When you crop things and you use something like Photoshop, Photoshop will give you different ratios that you can crop. You can get a 1:1, and a 1:1 means that you have equal sizes, height and width. And this box in here shows you a 1:1 crop. You could have a 2:3 or a 4:6. If you think about regular photographs that you take and you take them to get printed, they often give you a 4" by 6" format. In that, you're looking at 2 units on the side, 3 units across the top. This shows you a 2:3 format. Another one is 9:16. 9:16, we're talking about high definition. High definition says that it is 1920 by 1080 pixels. This is the format of the screen on most smartphones nowadays. And a high definition will actually give you this. Which one of these three do I want? If I'm putting this on something where you're going to watch it on a cell phone, I want the HD, the 9:16. If I'm putting it into something like a paper, I don't need this extra stuff on the sides. I can actually decrease the amount of fluff on the side and come up with a nice picture that will fill up a column, and it will give me plenty of information on it. So when we look at it, cropping is one of the things. Now I will put up a video on how to crop. Here's your three pictures in different formats. Your 1:1 on the bottom in the yellow, your 2:3 on the top, and your 9:16 on the bottom right-hand side. Which one looks better? Depends on what you want. If I'm showing this to an audience and I've got my PowerPoint, the top one will fill up a screen on the old PowerPoint format. The bottom one will fill up a screen if you go in there and you tell PowerPoint that you want it to be high def. The videos I shoot here are all in high def. So I would use the bottom one in order to be able to do this because it fills up the screen and it gives me a much better visual of this. Here's two pictures. These are actually the same pictures. What's the difference between the one on the left and the one on the right? You should be able to visualize that. And because you can tell by looking at them, they are different, but they are exactly the same photograph. What's the difference between the two? Number one, the one on the right is slightly larger in size. There's still a 1:1 format, and they are exactly the same size. You can see the height on these are exactly the same size. There's still 1:1 format. One is slightly bigger than the other, balloon size, not photograph size, but balloon size. The other thing you can do is if you pay attention to this, you will actually see that the one on the right-hand side is the lines in the balloon are absolutely vertical, whereas the one on the left-hand side is in its native format where it was slightly off-center when it was taken. Both of them reveal the same thing, but I'm sure you're looking at this and going, hey, wait a second, if I want to put that in there, I think the one on the right is actually going to give me a better view. You can see on the inside of it, you can see the flame coming up so that you can see, what we've got in here. Formatting, you can see that. And again, format you pick depends on what you're trying to look at. Depth of field. How much of the picture is in focus? Now, you can look at this and you say, what in the world? You got a bottle of whiskey up there. I got a bottle of whiskey up there because it's printed material. I figured the easiest way to look at these things is printed material. When you look at it, you can read the label on the bottle, and the question comes down to it. How much of the picture is in focus? The focus pretty good on the picture? Not bad, I guess, depending on what you're doing with it, right? Depth of field really goes in when you take a picture. It figures out how much of that image is actually going to be in there. Now remember, this is a flat surface. So the positioning of the camera, the angle of the camera and everything really determines how much of this gets into focus. Is what you want to see in focus. And on this particular picture, it doesn't look too bad right there. Well, let's see. If we go and we take the upper part of the label, that's all in focus. You can see your label in here. You can see how it's even blown up to this size. The focus on it isn't too bad because it's got a pretty good depth of field. You look at the bottom of it, you're going, whoa, wait a sec. Give me a new pair of glasses. That's horrible. This is the same bottle, taking the bottom part out and increasing it in size, and you get that, and all of a sudden you can't read that anymore. Because as you blow it up, the pixels become larger, and when the pixels don't have even edges on it, you get something that looks like this. This shows you a overall external view of the greenhouses. The College of Agriculture and Food Sciences located on the Florida A&M University campus. So you can see your figure legend in here, but what I want you to take a look at is on the left-hand side, there's that light. That light is totally out of focus. Even the center part of the greenhouses aren't too bad, but the edges are real bad. And a lot of this is due to the fact that when this picture was taken, it wasn't taken with a whole lot of depth of field. When we look at photographs, you want a photograph to be as clear and informative as you can possibly get out of it.